good afternoon, everybody. Our next speaker for the day is Karan Mali, and it gives me pleasure to introduce him. So Karan is one of our very own alumni from KLSGIT, and he was the General Secretary of the college during his period, that's in 2018 and 2019. And for the past 3 years, he has been associated with IBM. So initially as a cybersecurity intern, and now he's a full-time software engineer over there. And his work includes things like creating component-based UIs for IBM security verifies governance capabilities, and also working with complex JSON payloads and API integrations. So Karan also has many certifications in the field of cybersecurity, like the Security and Privacy by Design Foundations, the IBM Agile Explorer, Data Privacy Fundamentals, Think Like a Hacker, and Common Corporate Qualifier Test. So apart from this, Karan also has many honors and awards in various extracurricular fields, like in debates, extemporaries, mock press, and even paper presentations. So we're proud to have a talented person like him today. And thank you, Karan, for joining us.
Thank you, Varun. And especially coming from Varun, with whom I have shared some of these student activities during my time. So yeah, thanks a lot, Varun. And thank you, GCD sir and KLSGIT for inviting me. And I was just mentioning it to sir a couple of minutes back that the guy who was probably most of the times involved in all the co-curricular activities, both academic and cultural, is now ending up being giving sessions to the students. So it's fun. It's a good turnaround that you see in life. So yeah, I think today we can have, I hope we have a good session, and let's see how it goes and what is the key takeaway of the people who are attending the session. Okay, so may I?
Yeah, sure, Karan, go ahead.
Sure, okay. So I'll just be shutting the video for now. It helps, and let's come back when we have QAs on that point. So the topic that we have today for our session is blockchain. Is it the night of the cybersecurity realm? After my very thorough introduction, I think let's jump right into it. So what exactly are we aiming from today's session, right? So yeah, so in today's session, what we want to cover up is pretty much the basics of what we want to know about blockchain. What blockchain is, what was its starting point, what are some of the key cybersecurity advantages that come in a package with blockchain, and what are the security issues that have also come up with blockchain. The session is going to be pretty rudimentary. We'll be starting off and trying to develop the basic understanding of what blockchains is, and then we'll take it ahead from there. So I've just changed my slide, and I hope the change is also visible to everyone. So blockchain by definition is a shared or distributed immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. So pretty deep dive definition right at the beginning, which is filled with jargons of what's distributed ledger, what is immutable, what are transactions, and going on we will. And you have a small block diagram that also tells you that what exactly is a block of a blockchain composed of. You can see something that's an index, a timestamp, what is a previous hash, what is a present hash and what is the data in that block. So we will be coming and visiting these things. So let's just first make a basic understanding of how the blockchain comes into action. As each transaction occurs, it is recorded as a block of data, right? So whether it is buying, selling, creating something, or writing some form of data, it's all captured as a transaction, and that forms a block of data. And each of this block is connected to the one before it and one after it, which is pretty much what we saw in this particular diagram, where we see that the previous hash and the next hash are connected. And all of these transactions, when these blocks are stacked together, what we form is an irreversible chain. That this is primarily how the entire blockchain works, or how a blockchain is put together, how it's formed and how it's available for people. So now let's get into the jargons a bit, that what exactly are the key elements of a blockchain. Distributed ledger technology. So I think if people know anything about commerce or anything related to that, they'll know that there's a concept of journal ledger, where you write the transactions that are happening, which may be buying, selling, credit coming in, debit, whatever. And that is exactly the kind of thing that we are replicating in a blockchain. All network participants have an access to a distributed ledger and its immutable record of transactions. With this shared ledger, the transactions are recorded only once, and eliminating or duplicating a transaction is not possible. Right? So whatever is happening on that transaction. What was the net change that is being recorded? And that is what helps you also form the next block of data that comes into a blockchain. We have been hearing the word immutable now for 2 to 3 times, I think. So what exactly is immutable records? Immutable means you cannot tamper with it. You cannot change it. So no participants can change or tamper with any transaction after it has been recorded in the shared ledger. If the transaction record includes an error, then a new transaction must be added to reverse the error. So there's no concept of going back and being able to edit any information that comes in, right? And the third, and probably the most advocated element of blockchain, advocated because everyone wants to be able to take the maximum leverage out of smart contracts. It's a way to have speed transactions with the set rules, and all of it happening without any human intervention, right? And that's why it's smart. It can be applied to a number of use cases, as simple as getting a house on rent, where a smart contract is set in place. There are XYZ terms and conditions to be met. And if those conditions are met, a money transfer happens to the owner and the tenant is able to access the keys to the house. So as simple as that. Smart contracts are one of the major features which is being advocated by blockchain, and all the users who want blockchain applications are looking to make improvements in the smart contracts and pivot on smart contracts and utilize them in all of their use cases. So with these 3 elements and the 3 jargons that we saw earlier, that what is a distributed ledger, what exactly is immutable, what are transactions, I think with all those at place, we understand that what key elements of blockchain are and how blockchain has come into picture. What exactly were the origins of blockchain? Blockchain was initially put forward as an underlying technical framework for Bitcoin. So I know everyone today is talking about Web 3.0, cryptocurrency, this, that. And quite rightfully, Bitcoin and the paper that proposed Bitcoin is what also proposed a framework, which was blockchain, to be able to mine or create these digital currencies, right? And what are its current uses? So blockchain is finding its use in probably every field that is out there. FMCG, like you can trace the food right from the harvest, where you have where you come to know that, okay, so this fish has been caught, or this particular harvest has been completed, and these are the set number of processes or the areas from which my particular food element has gone through before it's arriving to my doorstep. Healthcare, I think one of the major concerns for any healthcare service provider is the ability to safeguard their records, being able to maintain the confidentiality of all the records that they keep, and ensure that those are not subject to any kind of attack. And blockchain is a great solution for these kind of problems, where all of these records, though being public, are still very much confidential, because there's no possibility of tracing back the actual identifiers. Finance. I think everyone is either very happy or very sad with the 30% tax slab that was announced for digital assets. And it has recently been the talk of the town once after our budget bills were passed. So decentralized finance is definitely a way ahead, and it's making digital assets transfers more faster, more convenient, more easier. There is a currency that is out of the control of any kind of governmental authority or any kind of centralized authority, and that in a way is very pleasing to people, and it's based on the projects on which these currencies come up, and all sorts of things, all sorts of good great things that we know about its implementations in finance. And I think one of the most common thing that we go to any bank and we listen that your KYC is not updated, please submit your documents. And I think blockchain's solution that if there are any edits to your records, those edits will happen. There's no duplication. And having your identity stored as a part of a blockchain is kind of the solution that we need to get rid of multiple submissions of our KYC. Supply chain, another great use case for blockchain, where you are able to track your supplies and be able to know that when a smart contract is fulfilled, so and so supply is going to take place and it's going to get transferred, etc. And last, of course, security, AI, IoT, networking, all the big words, all the keywords that you want to listen to anywhere and from anyone and everyone, all of those have some or the other addressings that come through blockchain, right? So this has been a very basic talk about blockchain that we have had so far. Now, what we want to talk about is what is the technical framework that we see when we see a blockchain. So I think this diagram is pretty much what we want to capture, that when in a blockchain network, there's a block and there's an owner. he has his own public key, and there's a hash value that he has, which is a part of the public key and serves as an ID of that particular owner. And he has its own signature. So each time there is something new that comes into the block, all of these verifications and signings from one's private keys and the other person's private keys come into picture. And what they allow is a completely decentralized way of having a consensus that this block is now acceptable to be a part of our framework or our particular blockchain. And as you can see, that if there is a hash value that is being generated of one owner, then it has its relation with the hash value of its previous owner, which we can see over here. If you see the owner two's public key and its hash value getting computed, then it has a takeaway from owner one's public key and owner one's private key, where it's assigning. So in the technical terms, or in the technical way to look at this, we have a very simple yet very complex framework that blockchain brings into the table. So blockchain and the CIA triad. So blockchain in general has security and privacy by design, and having security and privacy by design is the goal of any cybersecurity based system that one is creating. And the CIA triad, that's confidentiality, integrity, and availability, is what we want to be achieved by any such cyber systems. So the first and foremost thing that blockchain addresses by its design is confidentiality, where a blockchain user has the normal asymmetric encryption approach, where he has a private key and a public key pair. The private key is used to encrypt its data, and the encrypted data is available. The public key is hashed, and it's available as a hash value, which is actually an ID indicator of that particular user. There's no way that an ID indicator can track back the blockchain user. And obviously by asymmetric encryption, we know that just with a public key, which would be visible to any attacker, it's not possible to retrieve a private key. So this is how the privacy protection or the confidentiality perspective of the CIA triad is addressed by blockchain right from its design level. Okay, I see someone writing up some scratches on the PPT. Okay, anyways, probably a mistake. Let's go ahead. So tamper proofing or integrity. So the second aspect that we have of the CIA triad is the integrity, where we want to ensure that the data is not tampered, that the data that is being created in the block does not get any sort of updates or any sort of value changes or any sort of tampering that happens with it, because that's how we want to maintain the integrity of the data and make it completely tamper proof. So in the blockchain, you have data which has a generated hash and a timestamp server, which is also utilized to create a final generated hash. Now with this timestamp and with this data as combined, that is added to a block. Now this timestamp server is something which is not visible or not completely available to an adversary or a person who wants to attack, making it even more difficult and even more problematic for them to be able to change any part of the block or have any sort of any sort of attacks with respect to the tampering of data at place. The third part of the CIA triad, which is availability, disaster recovery or availability, which is a very, very big problem for centralized connections, where there's a single source of database and the attacker is just looking forward to attacking that particular database and be able to retrieve the information, perform any sort of malicious activities with the data, and be able to take down a system. What happens with a decentralized system in blockchain is that each of these blocks have a copy of the ledger. As we had seen that the ledger is shared or the ledger is distributed. So every time a new block comes in, a new block is added to the blockchain, there is another copy of the data that is formed. And if the adversary wants to attack, even if they're able to attack and take down any one of these decentralized blocks, there is a lot of blocks and there's a lot of scope to be able to recover from it and be able to have the data back in place. So in this format, we see that blockchain as a technology has security and privacy in it by design, and it focuses directly on the CIA triad, which is our sort of benchmark to understand whether a system is able to provide security and privacy or not, right? So now that we have been able to sort of get into how blockchains work, what exactly are our advantages from blockchain, and what we have been able to achieve with the blockchain as a technology, there are still a number of security issues that come in with blockchain. A larger decentralized network means a larger attack area. Even though we have so many blocks of the blockchain which are available, those are all still prone to be attacked, right? Those are still systems which can be compromised, and those are still systems which have the data for the entire network. And by design, to avoid any sort of DDoS, block sizes were originally meant to be around 1 MB. But because of that, the data storage capacity that one would desire in each block of the blockchain is compromised. Now, at this point, it's a discussion between being able to have more computation capabilities out of blockchain to being able to secure it more, right? The third one that we see is data mining and correlation analysis to retrieve valuable information related to blockchain applications, users, network structure, etc. So like we were talking, that larger decentralized networks means larger attack areas. So if you have a larger attack area in place, the possibility of even one of those blocks going down is very easy. And once one of those blocks is down, even though the data is in a hashed format or in an encrypted format, there are ways of data mining and correlation analysis, which will help the attacker to be able to sort of backtrack and calculate what could these possible data points mean, or what exactly could be the information stored in them. Then comes the consensus mechanism and how it is prone to the 51% attack if the nodes are dishonest. So a key feature of blockchain comes that whenever there is a new data that comes into the chain, all the nodes of that particular blockchain are get to know that, okay, this block is coming into the chain we need to validate it. And if we think that this block of data is validated, then that particular block can come into the chain. This is the consensus mechanism that blockchain has. And in that aspect, if there are nodes that are dishonest, or if there are nodes that decide to take down that particular blockchain network, then a 51% attack is all that they need. If 51% of the nodes say that this new information into the blockchain that is coming in, that's right, and it's added to the blockchain, whereas it is not correct, and it is actually an attempt to tamper the information, and it creates it falls back on the integrity part of the blockchain or the CIA triad, then that particular blockchain becomes vulnerable. It becomes vulnerable to attacks by DDoS, the entire tampering of all the records, new records being generated which might not have any sort of relation with the previous records, so on and so forth. And though the blockchain is very much concise with its security and privacy aspects and all of those, it does not solve the key problem of any cyber system. That's humans. In blockchains, the private keys, which are actually used to encrypt the data in the blockchain, which we saw a couple of slides back in how a block works, that entire key storing is completely dependent on the nodes or the users of the blockchain. And that forms one of the biggest issues, because if people are storing their private keys on some network or on some online platform or just written down somewhere, there is a high chance that it's compromised, right? The massive dependency on cryptography makes it prone to backdoors. Every node in a blockchain has hash, has encryption, and all of this is based entirely upon cryptography. And we know, and we have read, we have seen reports where some of the most long-standing cryptographic encryption algorithms are also breakable. Someone might just keep using hashcat and find out the underlying values of the hash addresses that they see, and they're able to be a part of the network and bring down the entire blockchain. Some more security issues that are still available is cross-border data transfer and its repercussions. Data goes unsupervised if users are across countries. Since blockchain is decentralized by its nature, a blockchain user can be located in any geography. And unfortunately, till today, we don't have concrete cyber laws which have equal weightage or equal judgments for any kind of cyber crime that happens, or any kind of data that is transferred from one country to another country. In Europe, you have GDPR. In India, you have practically very few things. And all of these mix and match of supervision in how data travels from one place to another is what causes repercussions. If a blockchain user has data from some country which is on a decentralized network, and then it's transferred as a copy to some other country, so it's in violation of a lot of those laws that are governed internally for them. Accountability, if blockchain is used for the wrong reasons. No way to backtrack the identity, right? So as we saw in one of the slides, that the ID is nothing but your public key which is hashed. And there is possibly no way to reconnect this public keys to the intended users who have created these IDs, which is exactly why if people use cryptocurrencies, they have wallets, and all of those wallets are nothing but addresses, hash addresses that are in place, that are being utilized, and there is possibly no accountability for any of these wallets or crypto holders or any kind of these addresses. And what happens if there is a crime? What happens if malicious practices and the payment and everything that's processed through the crypto network, but there's no way to trace back that who was accountable for these expenditures? The next two are what are kind of types of attacks which are coming up with cryptocurrency as well as blockchain and smart contracts, flash loan attacks and rug pull attacks. So we will go forward and see some of the popular attacks that have happened with flash loans and rug pull. But before that, I'll just take a small pause here. And if there are any questions, then probably I can answer them for whatever I have covered till now.
Karan, there is one question by Rakshit.
Okay. Yes, sir, please go ahead.
That is, can you explain how Bitcoin mining works?
Can I explain how Bitcoin mining works? Okay. I'm going to give it a shot, Rakshit. Thank you. So essentially what happens in a Bitcoin mining is that there is, so when Bitcoin was introduced, blockchain was its underlying network. So all of these digital currencies, whether it's Bitcoin, whether it's Ethereum or any other DeFi projects that we hear of, all of these are technically networks which are creating a digital asset or a digital data that is being created. And it's based on the computations or the blocks that are added to this particular blockchain. So if I were to explain to you that what happens when one digital token is transferred from, say, person A to person B, right? What basically happens is there is one wallet holder who says that this is my currency amount that I want to be a part of this, that I want to be processed by this network to create a block that is going to be added to the blockchain. That currency amount is picked up and taken into the nodes, and the nodes validate it. The nodes say that, okay, this is all fine, this goes through. And then that amount is processed by one of the miners' computers. So miner computers are basically the physical systems that are running these networks. And once that currency goes in, and that particular block is added to the blockchain network that we have for, say, Bitcoin or Ethereum, the processed amount or the processed value that you have of the coin is what you get on the other end, right? So the entire concept of mining is, in a broad way, running this entire blockchain network on a number of node machines. And when there is any sort of currency or any sort of operations that happens, it is run through this network. Now, we see that Ethereum has gained a lot of traction by being able to process smart contracts. So what exactly happens when a smart contract is processed or when a smart contract is built upon the Ethereum network? When a smart contract is built upon this, you have a process that, okay, whenever these set of actions or these set of computations are going to take place, the contract fulfillment is your end goal, and that is what is going to be a block, or that is going to be an entry into that ledger, that so and so contract was processed, and that is put there, right? So in the same fashion, for cryptocurrencies or currency units getting transferred, that is the whole concept, where you're actually you don't have a physical presence, because these are all virtual currencies. So the computations that you do on the network, or like we have for coins, proof of stake, proof of concept, all of these ways that a network is running, in that particular fashion, when any computation happens in the network and there is a block added or a block removed, you see that the miners putting it out as a digital currency, and that is what you get in a transfer. Does that give you a view of the things, Rakshat?
He has a follow-up question also.
Sure.
If all the systems in the network stops working, then will this Bitcoin mining and processing stops?
So, and that's a very good scenario to think of, that what happens if all the minor nodes are shut, all the minor nodes are dead. So in a pretty simple manner, the answer would be yes. That if all of these minor nodes are shut, if all of these nodes are compromised, you'll see that the entire coin circulation that you have, apart from what is remaining with the people in their own wallets, there's no more access. And that's how I think the coin burns. If someone trades cryptocurrencies like I do, then they'll be able to understand that there are often scenarios when we are told that 5 million coins of so and so companies burned, right? What exactly is that burning? They say that these coins are put into a vault from where it will never going to be accessed. So a simple meaning of that is that these blockchain nodes have been marked as something that will not be a part of the blockchain, and these are separated, or these are ousted. So if corresponding to that there are machines which are working as nodes which are also shut, then the access to those coins is now not possible. And once this access is not available to the people, what are you going to do with those particular coins residing in your wallet? In the wallet, the technology is fairly simple, that you have had some transactions, and you have based on that you have a coin amount that is listed in your wallet. But if the underlying network that is running that coin, that's supporting that coin, if all of those machines go shut and that network is down, how will you process that coin for any use? Or how will a coin exchange be able to, what will a coin exchange do with that particular coin, right? And I think we will see something similar to this in the rug pull attack that we have in the presentation ahead. Similar to this, not exactly this, but yes.
Thank you, Karan. There is a question from Bhaskara Kumar. Is
Yes.
blockchain safe?
We are going to find out that after I have enlisted all of these issues already. So we are going to just see that. So if we just run through both of these previous slides, right? Okay. Sorry. Yes. So if we see the issues of blockchain, then you are able to understand that though blockchain is a safer option as of now that we have, but it's not 100%. It never will be. I think because in every cyber system that is built, every cybersecurity system that is built, there is one aspect of human intervention built around it. And as long as those human interactions can be compromised, blockchain is also compromisable. So we have already enlisted all these issues, right? That there are a lot of ways where it's unsafe. I think the first one in itself, which breaks its CIA triad acceptance, that's that the confidentiality is not maintained in a blockchain. When you have better versions of blockchain like Hyperledger and all of those things coming up, these are further refined. But at the base of it, the blockchain's natural framework is not exactly 100% safe.
Thank you, Karan. There are no further questions. You can continue your talk.
Yes. So let's go ahead. So let's see some of the attacks that have happened currently, especially in and around the coins or the cryptos area, because I think blockchain has been most publicly available in the form of cryptocurrency, especially because it was unregulated. So Krypton, Shift are two blockchains that were based on Ethereum. So when Ethereum comes up with a framework, there are other blockchains also that can be built upon those frameworks. And both of them suffered a 51% attack in August of 2016. So 51% attack, that means 51% of those nodes were infected, I would say, and they were compromised. And because of that, a large amount of all of these blockchains was either destroyed, utilized, or in general term, it was compromised. And in May of 2018, we have Bitcoin Gold. At that time, it was the 26th largest cryptocurrency that suffered a 51% attack. The malicious actor and actors controlled a vast amount of this gold hash power. And even when the Bitcoin Gold, which is sort of the provider of this blockchain, repeatedly attempted to exchange their thresholds and be able to get hold of the situation, these attackers were able to double spend for several days. So double spending means that the amount of control that they have over the network, they were utilizing it to two-folds. And whatever the raise, the exchanging, the attempt to raise the exchange was, it was just being mellowed down. It was just being diverted. And eventually they ended up stealing more than 18 million worth of Bitcoin Gold. And the attacks on Bitcoin Gold have been continuous since that. So investing advice, don't purchase Bitcoin Gold. This attack is on the X token DeFi project attack, which is kind of what is generally happening today in the crypto market that we see. And this is a combination of how smart contracts are leveraged. So flash loan attacks are designed to take the advantage of artificially modified token prices. The attacker swaps a large amount of one token for a large amount of another token on a cryptocurrency exchange. This causes the value of tokens to change on that exchange because it has a different supply of each token. So one of the biggest governing factors of any crypto token's cost is the amount of supply that is available in the market for that particular token. What happens in a flash loan is there are providers like DYDX which allow you to purchase a chunk of these coins as a flash loan. And once you have this, using crypto wallets, you are able to transfer it from one chain to another, right? And that is exactly what happened here. So in this particular attack, the attacker borrowed 25,000 worth of Ethereum from DYDX and about 1 million SNX. SNX is the X token DeFi project part. And then they performed few different swaps on different exchanges. So they utilized the Ethereum that they had taken on loan to purchase a large amount of SNX. And then this combining the SNX loan that they had of 1 million and the 519K SNX on Banker, they sort of pumped all of these coins to another exchange called Kyber. Now, when the governing principle of a coin's value, which is being its supply in that particular exchange, increases so much, the valuation of that particular crypto coin hits and the valuation of that coin falls. And by doing these exchanges across, by doing these sort of buying and sellings across exchanges, they were able to push down the value of SNX. And due to these depressed values on one of the exchanges, they were able to take away a huge chunk of SUSDs, which are relatively stable coins, and they were able to deposit it and make money out of it, right? Though at the center of it, there was also programming error in the X token DeFi project, where the addresses of the people trying to purchase it was not properly verified in one of the required statements. But that was something which was not known to the attacker. What the attacker was doing was simply price pumping and dumping the coins. And we see this is happening as a very common trend even today in the entire crypto exchange. No matter which exchange you talk, you get a tweet from the great Elon Musk and you see a huge price pump, and then you see a huge price dump. So these are flash loan attacks, which may seem harmless, or which may be taken as market trends, so-called market trends, but there are adversarial attacks that come into picture behind all of these things, right? So this was again an example of the flash loan, and probably the most popular in recent times, which was a great example of the rug pull attack story that we have, which was the Squid Game crypto scam. So in recent past, there was a great Netflix series that came up, which was called Squid Games, and being sort of influenced by the popularity of that, anonymous creators created a crypto coin that branded Squid Games. Bunch of influencers and people on the internet who are tech savvy, they got onto the game and the promotion was that more people in the game, more the prize money would be. And the prices just went crazy. And people were like, okay, this is a new coin. This is the next big thing. This is the next coin that we are going to get our hands on and become crypto millionaires. But what happened at the end? Within a span of a week, and even before any analyst or any experts could expose the scam, the promoters of the coin liquidated all the cash that was given to them, and the shop was shut. There were no more crypto, there were no more owners or underlying nodes that we would say for the Squid Game crypto coins. And that's precisely an example of a rug pull attack, which was for a previous question, that what happens when all the nodes go shut. This is a simple example of that, where you, even if you're not running a blockchain or a network underneath, you just say that, okay, this is up and running and we have a crypto coin, we are giving you these digital things. And when we get all the money, the promoter, who is the creator of the coin, gets all the money and all these requests of buying the coin, which are actually proper cash, right? When you want to buy a coin, you have to deposit some INR from your bank account or some USD from your bank account. That is when you're able to buy these things on exchange. And they liquidated it, and it was just a shut shop, simple as that. So this is, I think, one of the best examples that we see of what happens when the network goes down. Because now what are you going to do with that coin? First of all, there was no option to sell those coins. Now that those options, even if those options are made available, Whom are you selling to? What are you going to do with that coin? Right? So in sort of a conclusive way, we can say that though blockchain does check all the boxes of security and privacy by design, like a knight's armor, it's not perfect, right? As the technology evolves and as there are going to be massive improvements, and some are already in place for blockchain, things will get more refined, that's for sure. But by the time these things are going to get refined, there are a lot of issues that can happen. There are a lot of scams that you can fall prey to. Uh, there is a lot of things that people want to do. Everyone wants to go, yes, we want decentralized finance. Why should the government control my finance? I have a decentralized finance option where there is a value of a coin based on how it is working and how it is processed. All of those things, these are great. These are absolutely great topics to talk on and absolutely great concepts. But until and unless we don't know that what is the accountability, what is the concerns that we are going to face more and more, what is the point of going all in on anything, on any technology that does not have a proven fact that it is going to be 100% secure? It is as good as safeguarding one data center of one company compared to one decentralized node being protected, right? Because if one node is attacked, you have all the information available. If the main data center of company is attacked, you get all the information, right? So in a way, all of these things combined, yes, blockchain is a great way ahead, but it still needs a lot of refinement. So any more questions coming up? Something from the professor also welcomed.
There is one more question from Rakshit. Yes. What we need to create our own new cryptocurrency?
I think, so if you want to create your own new cryptocurrency, then you can probably go ahead and utilize any of these available frameworks that you have, Ethereum being the most popular and the most common one, and you can build on it. You will find ample number of courses which tell you how you can develop an algorithm that's going to help you create a digital currency or any one of these frameworks. There are a number of coins that already exist on the Ethereum framework. So that would be my advice, that you go ahead, explore that, how that framework works, and how exactly can you make a coin or a cryptocurrency in that, and how you can host it. And before that, please wait for our honorable finance minister to shed more light on how you're going to be able to transfer those, because as security measures, there are a lot of things coming up, right? Especially in India. So yeah, I think the straightforward suggestion to that would be that you learn about the underlying frameworks on the languages that it's written, understand that, and how you can make your own smart contracts run. And I think smart contracts is probably a way more useful application of the framework, rather than just going all in on creating digital assets, right? So yeah, I think probably exploring the framework is your starting point on what framework you want your currency or your smart contract to function, and then you can take it above from there.
Just to add few more points, there's a problem in recognizing the cryptocurrency as a legal tender, because it may destabilize the economy of a country. In fact, economy of many countries. So we can go for it when government itself launches its own cryptocurrency. Otherwise, it's going to create a havoc, because it's a form of alternate currency, or it's a form of parallel economy. So that may create a lot of troubles for
Yes,
law enforcement agencies.
exactly. So as sir has rightly pointed out, that's why I said that wait for our finance minister also. What you see happening in China, or what you see happening in US, is exactly their form of countermeasures that they want to take, where you have USDTC, you have BUSD. These are coming up as digital currencies. And going forward, I think the most normal way where all of these will be sort of implemented, and this is my personal vision, is that depending on the country that you're in, your initial conversion is going to be into the digital currency provided by that particular country, right? So the moment you want to change your actual cost or your actual money, INR, into a digital currency or a cryptocurrency, the first phase as a precaution measure is always going to be the digital currency of that particular current country from where you're accessing it. So you will be compelled to first convert your money into, say, INR digital, and then go ahead with purchase of any of these digital assets. And I think, sir, that's kind of in line how we want the countries to be involved and to be able to take on what is going to happen next, and how can we avoid destabilizing of the economy while we also promote a digitally available currencies, right? That's why it has been addressed a lot of times as digital assets. Like stocks are an assets, they are an asset class which you take money and you invest on it, and then how it grows is how you understand. So in stocks, there is a very beautiful metric of companies, where you know what the company is doing, what the company is going to be delivering, and that's how the valuation of that comes up. So what happens with these currencies? These currencies are not of any tangible value, right? Those are just virtual existences. What is of value is the framework, the blockchain framework that works beneath it. So that framework is going to enable being able to process, as we said, smart contracts, supply chain problems, XYZ. So the more use of a framework comes into place, comes into picture, that will govern the cost of that particular of the coins that are sort of hosted on that networks, on those blockchain networks. And I think that is a far much more explanatory way of being able to determine the value of any coins.
Thank you, Karan. Are there any questions by participants? So you can ask your questions. You can post the questions in the chat window. Still, we have got plenty of time.
Yes,
and we begin with the next session.
Precisely. That is why, since this was going to be the first talk of the session, and you also have a very good talk again in decentralized networks that is going to be delivered as a part of Winter School, which you should attend. This talk is kind of, you can say, a prequel to that, which kind of gets you on board in what decentralized as a buzzword is. What are the security aspects that we see? Because if we talk about a winter school in cybersecurity, that is going to talk about what basics of cybersecurity must be covered by any technology that we see coming into picture. And that was what I wanted to be a part of this talk, that inherently what all blockchain is solving, and also what all issues does it bring along with it inherently, right? So people are very fond of currencies, I would say, but I would really urge people and students, researchers to take more part in the other applications of blockchain, which are also available. You can go ahead and check IBM's exhaustive portfolio of all the things that they do with blockchain, starting from managing ships, locating ships, the weather report, to n number of FMCG related, supply chain related issues that they are solving using the IBM blockchain network. So it's going to be a great read if people go ahead with it, and you will be able to self-identify that such great dependencies of security are getting covered with this.
Yeah, thank you, Karan. That's a very important point, because when we think of blockchain, people usually think of Bitcoin and cryptocurrency only, but there are lots of other use cases.
One of the most brilliant use case, I think, which as students would come, sir, is what happens when you are talking about meta and when you think of the entire process of learning or schooling to be on the web, and how blockchain comes into picture in that, from from a student's virtual identity of that particular college to their final report cards. All of these are things that are necessary to be secure, and I think blockchain is going to be a great solution for allowing these things.
Yeah, correct. Yeah, there is one more point I think you can highlight in a much better way. Generally, what happens is whenever new technology is introduced, or whenever new technology comes into market, everyone just run behind that particular technology. Say, for example, when we speak of AI/ML, everyone wants to do AI/ML. Again, similarly to AI/ML, blockchain is also a buzzword. But blockchain is not the solution to every kind of application.
100%.
Yeah.
And so, yeah, I think it's very rightly said that when we want to talk about any new buzzword, I think everyone starts running into it. That's very fair. When you look at the structure of a block that you see in a blockchain, what is the first thing that it reminds you of? Nothing but linked lists, right? That is how fine-grained these things are. So if you think that you are going to use linked list in your everyday, say, a programming assignment to find out if a number is odd or even, then it's, I don't know what kind of implementation is that, whether it's okay to call it unthought of instead of using a more severe word. I would say it's an unthought of use case, right? So in the same way, when blockchain is also coming up, and when blockchain as a technology is not just something that you can just think, okay, I'll put it here, I'll put it there, and it's done. No, it has to be from the framework level before going to currency, before adapting it for every XYZ thing that you find out. Look for the use cases that it's actually going to bring value to, and it's actually a good choice to replace what currently is there. Now, if you see for a large organization, when we talk about data integrity and data confidentiality, if there is a large organization that has its servers located across the globe, it may look like at the outset that why don't shift all of this into blockchain? It becomes more secure. It's already decentralized. There's no issues. There are issues, right? Each of these governing data centers are governed by those countries' laws. So you nullify, one of your advantages is destroyed. Second thing, if all of these are decentralized networks, all of them are attack points. Any one of them is attacked, companies' most sensitive data are in danger. Whereas if it's a centralized server in some other places, there are casing on casing of security protocols, security aspects that you can add to it, right from adding customized firewalls to access controls, etc., all of these things. So like sir very rightly pointed out, that you need to identify the correct use case where you need it. I think smart contracts and uh, especially tracking of records is a very good use case, where these can be the first set of implementations, and students should also try that as a part of their academic projects to work on these very simpler use cases first, which are valid use cases, and make you understand the framework beneath as well.
Yeah, thank you, Karan. So I just want to point everyone to one resource. There is a small book on blockchain, that is Blockchain for Dummies. I think it's written by Manav Gupta. He's from IBM, I guess. It's a very small book of 50 pages. There is a chapter in it that is 10 steps to create first blockchain application. I think that's a wonderful resource that will give you insights to everyone, whether to go for blockchain or what are the possible use cases for blockchain.
Correct.
Yeah.
And I think there is one I have advocated this. I'm putting it down on the chat. There is one website called cognitiveclasses.ai. I think there's a space that came down over there. So I think it's a good place for you to learn. Again, this is also powered by IBM, but the courses are free. The courses are available to all. You can have education and get basic understandings of not just blockchain, a bunch of other things, but it's definitely a lot of work around blockchain. And I would suggest that you follow these projects, like you follow Ethereum as a project, not as the coin, or you follow say Matic Network Polygon. You follow it as a project on blockchain rather than a coin and whatever money making that can happen with it, right? So yeah, I think just to add to sir's book suggestion, I think cognitiveclasses.ai is going to be a good starting point to learn both theoretical and practical aspects of blockchain and other technologies.
Thank you, Karan, for the website link.
Yes.
I request participants to ask questions if there are any. So we'll wait for a minute, Karan.
Sure, sir. Sure. And I think precisely I wanted this talk to be crisp as well as introductory, because there's a lot of information coming your way during this winter school. So please be available for all the sessions. The speakers are great and you're going to get a lot to learn.
I think there are no more questions, Karan. Thank you so much for accepting our invitation and delivering a wonderful talk.
Thank you, sir.
It was a really nice talk which gave introduction to blockchain to everyone. So I think participants can start exploring it now. Thank you, Karan.
Thank you, sir. Thank you so much. And I surely hope that soon I will be able to be more useful for the entire community and deliver some more great talks with the OWASP as well as the initiatives that are taken by KLSGIT. And a very heartfelt thanks from my end to first of all GCD sir, who has been sort of championing cybersecurity in the college as well as in Belgium, and to all the college authorities who have come forward to do events like this. I think we do need events like this, and going ahead, let's make it a lot more bigger, a lot more focused on hands-on sessions. And I think, yeah, that would be great. And we'll be able to bring everyone up to pace for cybersecurity. And I think that's the main intention of GCD sir, as well as I am also a very big advocate of that everyone should know everything about cybersecurity.
Yeah, thank you, Karan, because we need your help, because we are trying to establish a center of excellence in cybersecurity at our institute, and it's going to be a very big project which we have undertaken, and we surely need your support.
100%, sir. Always there, always there for GIT. Never said no to any of the talks. Not going to say it ever again. So yeah, think. Okay, sir. Thank you for the invite. Thank you everyone who took time on this Saturday afternoon to be a part of this talk, and hope you follow up all the other talks in winter school as well and have great knowledge sessions with that as well. Thank you.
Thank you, Karan.